I am Anil Kumar. Welcome to my series on vectors. In this video, we'll discuss a test paper. I have picked up 12 questions from previous 5 years test papers. These should help you to understand the topic and also improve your performance in the test. The questions here are based on Introduction to Vectors, where we are going to include vector geometry, vector algebra, scalar multiple, and dot product. There are 12 questions in all. You can, in between, anytime, pause, answer the question, and then look into my suggestions. Let's begin with question number 1, which is straightforward. Fill in the blanks. Identify minus 10 degrees Celsius temperature as scalar or vector. Now, we do have positive and negative signs for temperature, but that does not give you direction. So whenever we talk about temperatures, it is a scalar quantity. Very important to remember, as sometimes students think this is a vector, which is not true. Part B. Express north 25 degrees west as a true bearing. Now, bearing angles are always measured from north in the direction, clockwise direction, right? We are given from north 25 degrees west. That means something like this. So that is 25 degrees west, right? So this is the direction which is given in the given question. What we need to write is the true bearing angle. Now, bearing angles are measured clockwise from north. So that means we are looking into this angle, correct? So that should be 360 minus 25, clear? So it should be 360 degrees minus 25 degrees, right? So that should give you 5. 5 take away 2 is 3, 335 degrees. So that is the true bearing angle, correct? So the true bearing angle is 335 degrees. C. Express as single vector. So vector FE minus vector GE plus GH. Now whenever we type, bold letters will indicate vectors. Now minus GE could be written as plus EG. So I could write this as F to E, right, this vector, plus E to G plus G to H. So clearly we are moving from F to H, correct? F to E, E to G, G to H. So that is how easily you can actually do or solve such questions. Next one here is determine vector AB given. So these are the position vectors given. A minus 3, 2, B 3 minus 5. So in this case, what is AB equals to? So AB will be OB minus OA, right? Basically, it is OB minus OA, correct? That is from A to B. So you could do like this. So B is 3 minus 5, take away minus 3, 2. So 3 minus minus, that gives us plus 6, and minus 5 minus 2 gives us minus 7. So that is the vector AB. So you could write vector AB as this is written in the column form. You could also write this as 6i minus 7j, right? Where I and j are unit vectors, and that is also correct answer, right? So you could write AB also, vector AB as 6 minus 7. Now let's take question number 2. Given that magnitude of A is 6 and magnitude of B is 4, and the angle between them, A and B, is 37 degrees, calculate A dot B and A plus B. So there are two parts to this. So first let's do A dot B. So So the dot product is magnitude of A times magnitude of B times cos of angle between them. So angle is given to us. So we can write this as 6 times 4 times cos of 37 degrees. Correct? Now let's calculate. So we have 6 times 4 times cos of 37 degrees. That gives you 19.167, right? Which you could round as, let's say, 19.2. So that becomes your dot product. Now let's find what is the sum of these two, B. Important thing to understand here is that when we are saying that magnitude of A and B is given and the angle between them, then basically, let's say this is A for us, right? And magnitude of B is, let's say this is B for us. The angle between them is 37. But when you do when you add the vectors, in that case, you draw a vector parallel to B here, right? And the resultant is the sum. So A plus B is this vector. That is A plus B. Clear? If this is A, this is B. That is also B. Now, the angle which we take is not 37, but it is 180 minus 37. Clear? To apply the cosine law. So we have 180 minus 37 equals to 143. So this is the 143 degrees which is being used, right? So A plus B, so we have both magnitude and direction, right? So let's first calculate the magnitude of A plus B, which is going to be, let's say square of this, let's calculate, we'll do square root, is A square plus B square, magnitude of A square plus magnitude of B square, minus 2AB cos of this angle, right? So minus 2AB cos of the angle 143 degrees. Clear? So in this case, it is going to be 6 square plus 4 square minus 2 times 6 times 4 times cos of 143. So we get 6 square plus 4 square minus 2 times 6 times 4 times cos of 143, which is equal to 90.33. So the magnitude of A plus B is going to be square root of 90.33. So let's do square root of our answer, and that gives you 9.5. So we get this as 9.5. So this is A plus B, magnitude is 9.5, right? Now we need to find this angle which it makes with A. Only then the vector is completely defined. So you should have direction and magnitude. We found the magnitude as 9.5 units. Clear? To get this angle, we can use cosine law or sine law. One angle, we have 3 sides, sine law should be used, correct? So now to find that, we will use sine law. Okay. So let us say that we now calculate the angle alpha which the sum makes with side A. So in that case, sine alpha over side B, right, this side B, should be equal to sine of angle 143 degrees over A plus B, magnitude, right? So magnitude, is that clear to you, right? So let's do it. So we get sine alpha equals to magnitude of B times sine of 143 degrees divided by magnitude of A plus B. Clear? So that is magnitude of B is given to us as 4, right? Over, we just calculate this as 9.5 sine of 143 degrees. degrees. Let's calculate this. So we get 4 divided by 9.5 times sine of 143, which is 0.253, let's say 4. Now alpha is sine inverse of this, right? So we'll find alpha, the angle, as sine inverse of 0.2534, which is, so we do shift sine inverse of our answer, and that gives you 14.67 degrees, correct? So we can say that A plus B makes an angle of 14.7 degrees with A, right? So we have our answer here. So we know now that A plus B, the vector A plus vector B, has a magnitude of 9.5 units and it is 14.7 degrees with vector A. Clear? So that is how you are going to get the sum of these two vectors. So I hope the steps are clear. Very important to understand is that when you want to find the sum, you should calculate both magnitude and its direction. Direction can be given with reference to one vector, any one of those two vectors. Clear? Now here is question number 3. I'd like you to pause the video, answer it, and then look into my suggestions. Number 3. Given vector P as 3i minus 5j, Q as minus I plus 4j, determine x if 4p minus 3x equals to 7q. So let us assume that vector x is let's say AB, right? So let's say vector x is AB. In that case, let's substitute the values and find the answers. We get 4p, so 4 times p is 3i minus 5j. I can write 3 minus 5 minus 3 times x, which is AB, right, equals to 7 times q, which is minus 1, 4. Clear? So that gives you 4 times 3 is 12 minus 3a, and 4 minus 5 is minus 20 minus 3b equals to minus 728. Clear? So from here we actually get two equations. The first one here is 12 minus 3a equals to minus 7, right? So from here we can find the value of a. The second one is minus 20 minus 3b equals to 28. From here we can find b. So let's find a first. So taking 12 to this side, we get minus 3a equals to minus 7 minus 12. So that means minus 3a equals to minus 19. So a equals to minus 19 over minus 3, or 19 over 3. As far as b is concerned, we get minus 3b equals to 28 plus 20. So minus 3b equals to 48. b is equals to 48 over minus 3. So which you get as 3 times 1 negative, right? So 18 is 6. So b is minus 16. Correct? So you get the vector x as equal to 19 over 3i minus 16. These are unit vectors j. Is it clear? So that is how you can actually find the solution of this question. Let's move on and take question number 4. We are given two vectors u and v. Determine if the above two vectors are perpendicular. So perpendicular means dot product should be 0, right? So that is the concept. So let's find the dot product. So let's find what is u dot v equals to. So we have here minus 3 minus 2, 2 dot 2, 5, 8. So that gives you minus 3 dot, this gives you minus 6. When you multiply these two, you get minus 10. And when you multiply 2 and 8, 16 plus. And that is indeed equals to 0. So this implies that u and v are perpendicular. Clear? Let's take the next question. Given A and B are perpendicular vectors such that magnitude of A is 5, magnitude of B is 3, evaluate this vector. Okay, so now we are given that A dot B is equal to 0. We have to evaluate this, which is 2A minus B dot A plus 4B, correct? So let's do the dot product. We get 2 A dot A, right? Plus 2 times 4, 8 A dot B minus B dot A. Now B dot A and A dot B are same things. Dot product is commutative. Minus 4 B dot B. Correct? Now A dot A is magnitude A square. And A dot B is given to us as 0. A dot B is 0. And here we get 4 magnitude of B square. Clear? So we get 2 times magnitude of A is 5 plus, minus 4. Magnitude of B is 3, 3 square. So we get 2 times 25 minus 4 times 9, which is 50 minus 36. Okay, so we get 4, take away 1, 14. So that is the answer, correct? The next question here is question number 6. Given the points P, Q and R, show that P, Q and R are collinear. So you can actually pause the video, answer this question, then look into my suggestions. Now in question number 6, we need to show that 3 points are collinear. So we could do that if we have scalar products. That is to say, if we prove that PQ is some constants times QR, then they are collinear. This is the concept. Is it okay? So let's find what is PQ and what is QR. So PQ will be what? P to Q means 1 minus, so X values 2 minus 1, let's do like that, 2 minus 1, 1 minus 3, 1 minus minus 2, 1 plus 2, right? Which is 2 minus 1 is 1, 1 minus 3 is minus 2, 1 plus 2 is 3. Okay, so that is the vector PQ. Now let's find what is QR. So QR will be 6 minus 2, minus 7 minus 1, 13 minus 1. Which is 6 minus 2 is 4, minus 8, and that is 12. So 1 minus 2, 3, 4, minus 8, 12, right? So basically, we can say that PQ, if I multiply PQ by 4, I get QR. So 4 times PQ is QR. Or I could say PQ equals to 1/4 of QR. That means they are collinear. Is that clear, right? That is how you're going to prove it. Here is question number 7. The vertices of parallelogram A, B, C, D are given to you. Using vector, determine the coordinates of D. So let's sketch one. Okay. So let's say this is a parallelogram. That means the opposite sides are parallel and also equal, right? So we have A, B, C, D. Let's write them in order. Coordinates of A is -3, -4. Of B is 5, -3. For C it is 1, 4. And for D we need to find, so let's write x, y. Now, since we need to find the coordinates of D, what we could do is that we know AD is equal to BC, right? So that should help. So we know AD, vector AD is equals to vector BC. Now what is AD vector? So vector AD is x minus -3 means +3, right? And y minus 4 means y plus 4, correct? Equals to B to C means 1 minus 5 and 4 minus -3 means 4 plus 3. So that means we have x plus 3 equals to 1 minus 5, which is -4, correct? And so that gives us x equals to -7. The other one is y plus 4 equals to 7. So y equals to 7 minus 4, which is 3. Right? So we get the vector D as coordinates for D will be -4, 3. Is it clear? So we get this as -4, 3. So that is part A. Well, x was -7. I wrote -4. It is -7 here. So good time to see it. Okay. So we got the coordinates for point D. Point D is -7, 3. Right. So we've done part A. Part B. Using vectors, determine if ABCD is a rhombus. Now, to show that ABCD is a rhombus, we need to find magnitude of AB and magnitude of BC, right? Then we can show that both are equal, only then it is a rhombus. So let's find magnitude of A to B. So AB magnitude will be equal to square root of 3 minus, let's do 5 minus, that means 8 square, plus -3, that becomes -1 square root, correct? Which is 64 plus 1 square root, or square root of 65. Let's find BC magnitude, right? Okay. Magnitude of BC, we already found BC is this, which is 5 minus 4 square plus 4 plus 3 is 7, 7 square, right? So that is 16 plus 49 square, which is also equal to square root of 65. Now, since magnitude of BC is equal to magnitude of AB, we know this parallelogram is a rhombus. Now, I'll recommend that since we are given these 3 vertices, you should calculate their lengths and then prove part B. So in case you have done some error like this, at least half of the question will be right, correct? 8. A circle has center O and radius 6. OA is a vector 6, 0. OB is a vector -6, 0. And OC is vector 5 square root 11. Determine a vector of magnitude square root 3 in the direction of CA. So let's make this circle here. This circle is of radius 6 units. We are given 2 points which are basically the x-intercepts. One of them is A, 6, 0. 6, 0 means this point. Let's say this is A, which is 6, 0. Then we are given B, which is minus 6, 0. That is B. We are given C, which is somewhere here, 5 square root of 11. Point C. Determine a vector of magnitude square root 3 in the direction CA. So in this direction CA, we need to find a vector whose magnitude is square root 3. That is the question. So I hope the question is clear. You can pause the video, answer, and then look into my suggestions. So what is CA? Let's figure this out. So CA, let's say this is O. CA, vector CA will be equal to C2O. You can write this as C2O plus O to A, right? So that is CA, right? So you could write CA as CO plus O to A. So that is CA, correct? So we have C2O is basically 0 minus 5. So we have minus 5 minus square root 11 plus O to A, which is 6, 0. And that gives you minus 5 and 6 gives you 1, and 0, this gives you minus square root 11. Right? You could do like this. You could also do directly. You can do 6 minus 5, which is 1, 0 minus square root 11, that is it, right? So you could do directly also, but that's an alternate way of doing it. Now we need to find a vector which is a magnitude of square root 3 in this direction. So here, first we need to find the unit vector and then multiply by magnitude of 3. Is that clear? So we need to find unit vector now. So to get unit vector in the direction of CA, let's write like this. Unit vector normally with a cap on the top. So will be CA divided by the magnitude of CA, correct? So in this case, our vector is 1 minus square root of 11. We'll divide by the magnitude. That means 1 square plus square root 11 square is 11, right? So that means 1 over square root of 12. So 1 plus 11, which is square root of 12. So that becomes the unit vector times, we can write times like this, right? 1 and minus square root 11. Clear? So that is how we could write this particular vector. Now, square root of 12 is basically 4 times 3. So you can write the 2 square root 3. Right? So either way you could write your vector. So you can write column or row form. So let me write down in the column form once again. 1 minus square root of 11. Correct? So that is unit vector. Now to get a magnitude of square root 3, we are going to multiply this with square root 3, right? So square root 3 times the unit vector CA is our answer, right? So we'll get square root 3 times 1 over 2 square root 3 times this vector 1 minus square root 11. Is that clear to you? So square root 3 will cancel. So you get your answer as half of 1 minus square root 11. Okay, so that becomes your vector. Clear? Or you could also write this as half I minus square root 11 over 2j. Either way. So that is a vector in the direction of CA with the magnitude of square root 3. Is that clear? So that is how you could answer this question. Let's take a break here, and in part 2 we'll do rest of the questions based on introduction of vectors. I hope you have understood the basic concepts, and we'll take up some applications in part 2. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.